We have been working with sequences a lot, and the other side of all this is we're going to be needing to discuss series as well. So we'll get to that in just a minute. This is going to be a longer video, so if you need to pause it and resume it at another time, please do. Okay, when we have a sequence, what we can do is we can look at the sequence and we can add, subtract, do something with the members, right? Particularly if we add them, we obtain a partial sum, right? So we can add, say, the first 5 terms and we get the sum of the first 5 terms, right? And we would just represent that as s sub 5. If we were to sum the entire sequence, and if we assume it's infinite, then we would just say we have S, okay? When we look at either of these sums and represent them mathematically, we get what we call a series, okay? And so a sequence, remember, I'm assuming it's infinite, and we're just using a slightly different notation with those curly braces in there, but it is just the sequence. If we sum the first n terms, we get what we call as a finite series. So a series is just a sum of terms of a sequence. And there's this big, scary notation, okay? So we have S sub n. So this is the Greek letter sigma, okay? And for us, all this means is that we sum, okay? And this is a typo. That should be a 1. I didn't catch that. Sorry about that. But down here, there's some important information given to us. So I, we call the index, okay? And this is just kind of allowing us to iterate through the sequence. But then this is actually telling us start adding here. So start adding when I is equal to 1, and end adding when I, your index, gets to n. Okay, so for example, when we have a sub I, that means start adding when I is 1, a1, and then continue adding members of the sequence until we get to when I is n or an. Okay, so effectively add everything from a1 to an. Okay, so work with that notation a little bit, and it'll come. It takes some time though. And similarly, if we were to add all the terms in the entire infinite sequence, then we get what we call an infinite series, which is just going to be the sum of all the different terms. Okay? So we need to get practice with this series definition, yeah, and this big scary sigma symbol. Okay? So we have some examples. First, in the upper left, again, this means start adding when I is 1 and end adding when I is 5. Okay, so when I is 1, I'm going to have, let's see, 1 times 3 is 3, plus 1 is 4. Okay, and maybe it'll just help if I do this in a table form. So I, and then this 3i plus 1. So I want to add from when I is 1 to when I is 5. Okay, so when I is 1, we got 4. When I is 2, right, I would put in 2 for I, get 6 plus 1 is 7. I is, okay, so then this is going to be 10, and you can start to maybe see the pattern. 13 and 16. Okay, so then I need to get out a calculator and add these all up. Let's see, I'm going to look for 10s, and this is actually pretty nice because I get a 20, a 30, and 20 more is 50. Okay, so then this whole thing adds up to be 50 because all I'm doing, this, again, this term, or this sigma means sum, and so there we go. Add up all the terms, and we're good. This next one, okay, I'm going to begin with the same approach. It might be helpful to do an I and then this negative 1 to the n plus 1 over 2 to the n table. And it says add when I is 2 to 5, 3, 4, 5. Okay, so let's see, this negative 1 to the n means that all the evens are going to be negative. So this is just going to be a negative, and then 1 over 2 to the 2 is 4, and then this will give positive 1 over 2 to the third, which is 8, and then this will be negative 1 over 16, and then 1 over 32. Okay, and to add up all of these, so I would do negative 1/4 plus 1/8 plus negative 1 over 16 plus 1 over 32, and I would get negative 5 over 32. Okay, so there we go. Next one, this is actually kind of a fun little sequence because it looks just very deceiving. It's like you sum 4, okay, but keep in mind that this means that if you look at k and then the sequence of 4, right, k is, you would add up the first 4 or first 5 terms, but each of them is just 4. So all you have to do is take 4 times 5, because you have 5 4s, and you get 20. Oh, that wasn't too bad. This last one, I want you to pause the video, try it out. This is a trickier example, but maybe this table approach will help you. And I got 38. Okay, I just defined that inside part of the sum as aj for the sequence rather than writing it all out, and then I made a table, and I got my answer. Okay, so now what do? We want to be able to not only determine the value by looking at the members of the series, but also go in reverse. Can we represent these using summation notation? Okay, well, so for each of these, I know that there's going to be a sum. Okay, and then you get to write this fancy symbol. That's really why we're doing this, is we really want to write this fancy symbol. And there's going to be an index. Okay, and I need to determine my start and end, and I need to determine the sequence, but the hint is actually to find the sequence first. Okay, so if I were to imagine that there were commas here instead of addition signs, right? So let's just get rid of those here for a moment. What is going on? Well, it looks like in the numerator, I'm going from 3 to 6 to 9 to 12. That looks like I'm taking whatever the term number is and multiplying it by 3. Oh, okay. Similarly, this is 4, 16, 64. So these are all powers of 4, specifically 4 to the n. So all I have to say is that, well, that's the sequence, right? In a series, you're just summing the members of the sequence. So this is going to be 3i, I'm just using I instead of n, over 4 to the I, where, okay, I would have to start at 1, okay, and end at 4. Okay, so you can double check this, but this means, so just to double check maybe the beginning and ending spot, if I is 1, it'd be 3 over 4. That'd be the first term. And for the fourth term, it would be 3 times 4 is 12 over 4 times 4, or 4 to the fourth, which is 256. So, seems to work. Okay. The next one, okay, I'm taking a moment to look at the sequence. Okay, so again, just imagining that there's no addition signs in there. It looks like the denominator, I can see that is 7, and then I'm multiplying by 7 each time. So it's 7 times the term number, n. Okay, so that's fine. The numerator, 2, 6, 24, 120, those are the factorials for the term number. So it seems like it's n factorial. So I'm just going to say here that I begin, or the sequence is I factorial over 7i, okay, and then this would begin with when I is 1, so 7 in the denominator, and then the, actually, I'm sorry, this is going to be not n factorial, this is n plus 1 factorial, since I begin with 2. So this would be I plus 1 factorial, and then begin and end at 4. Okay. So the last one, I want you to pause the video, try it out on your own, and resume the video when you're ready to see the answer. And here we go. So -1 to the n to capture the alternating aspect of the odd terms, alternating value, I should say, of the odd terms. The denominator, I noticed that those are powers of 5, so that's 5 to the n. And then the numerators seem to follow the cubes, so n cubed. Okay. Lastly, these you may or may not get to use these, but I just wanted to make you aware. When we're dealing with sums, we have 3 nice properties. I should say these are for finite series only. Okay, there are corresponding ones for infinite series, but A, we're not going to see them. B, there's some other extra conditions you need. So notice that all these series end or have an index that ends at n, but it just says that if we are adding a constant some number of times, from 0 to n, this should actually be 1. I'm sorry, these are all 1s. I forgot to change the indices. But from 1 to n, we're adding it n times, it's just c times n. If we have a constant in the sequence, we can pull that outside the sum. And similarly, if we have addition or subtraction of 2 sequences inside, we can break that apart as the sum, or the sum of 2 distinct series that are finite. All right, so thank you for following along in this longer video, and now we have sequences and series under control for a little bit, and then we'll get some more practice on specific types of sequences and series next time.